Okay, so we'll start the session now. So, do you have any questions which you want me to discuss or some conceptual doubt? Yes.
So I have doubt in some skid error. What is like some skid error?
Sorry.
Some skid error.
Um, week 4, right?
Yeah, week 4.
Yeah. So, can you tell me what is your doubt?
What is some skid error?
Scared? Sorry,
1 minute.
I
I
think
will
he's
type
talking
it.
about sum squared error, SSE.
okay.
Yes, yes.
Okay, some squared error. Okay, so that is something different, right? So that is not in week 4, right? This is in
Yes,
week 3.
but there is a question of some skid error in week 4.
Okay, so there is a sum squared error in question week 4, practice assignment, you are saying?
Yes, sir.
Yeah, so have you studied sum square error in week 3?
Yes, sir, but I am not able to understand that. Can you please let me understand that?
Yeah, just give me a minute.
Sir, is the doubt solving class regarding week 4 only?
Not like if you don't have any doubt from week 4, then probably we can go back and discuss few questions from previous weeks also. No problem.
Oh, okay, sir. Only for doubts section, no? It is not like question solving.
No, if you have no, certainly I don't have anything to solve. Like if you have some conceptual doubt or any questions, like any doubt on your mind, then also I can solve. Like if you have only, so yeah, I'm going to take only your doubts. I'm not going to solve any questions from my side. Can you see my screen now?
Yes, sir.
Yeah. So yeah, so this is the question, right? This is
Yes,
the
sir. This is
this is the question you have doubt, right? So
yes, sir.
so so in generally how you find this sum square? Suppose you have a line, okay, right? Suppose you have a line, right?
Yes,
Let's
sir.
suppose this is your line y equal to, let's say, 2x plus 3, right?
Yes.
And you have bunch of data, okay? Let's say you have 3. I'm not going to take more than 3, okay? Again, like it doesn't matter. So this is, let's say, so this is your xi and this is your yi, right? So let's say for xi equal to 1, your value of yi is 5.
5.
Okay. Not it's not, so this yi is not related to this thing. Okay. I'm just taking some random thing. Okay.
Okay,
So
sir.
so this is random. So this information has nothing to do with this function. Okay.
Oh,
So at 2, let's say it's 11. Okay. And uh, at 4, let's say it's 2. Okay. So these are the data which is given, right? Okay. So so you want to find the sum square error uh, for this line, okay, for this line with respect to this given data, right? So you want to find SSC, right? So how generally how you do it for a line? Can you tell me how you do it for a line?
sir, some skid error for a line.
Yeah, yeah.
I I think in the graph of line is straight, so we don't need to find some skid error like something like that.
So have you studied the sum square error in week, I guess in week 2, right? Sum square error is in week 2 for a line. How you find sum square error for a line? Have you
No, sir.
studied?
No, sir. I think
Okay.
I
So
don't.
okay, so in generally what you do, okay, so first what you will do, you will put this value y x, so this is your x1, right? So what is x1? X1 is 1, right?
Yes,
And
sir.
x2 is 2 and
Yes, sir.
x3 is 3. X3 is 4, sorry, right? So these are the
Yes.
xi's. Okay. So what you will do now, you will substitute this x1 in this equation, of the line. Okay. So what you will get now? If you substitute x1 equal to 1, what you will get?
I will get 2, 1, 5.
So 5. So you are getting 5. Okay. So then what you will do? You will subtract this 5 minus y1. Okay. So what is your y1 here?
5.
Y1 is also 5.
Yes, sir.
So this is 5. So you will subtract this and you will take the square, right? Similarly, you will do for x2 as well as x3
Oh,
also. Okay, so now
yes, sir.
again if you substitute x2, what you will get in the
7.
this is 7, right? 4 plus 6,
7.
7. So now what you will
7.
do? 7, and you have to subtract with
11.
11, correct. So 11, and you have to take the square, right? Sip case up. Yeah, if you have doubt, you just let me know. In particularly in this question, okay. I am not going to take in some different question now. Okay, once I finish this, I will go for different question. So, so then what is the next thing? It's 4, right?
4.
So again, what I will do? I will substitute 4, right?
11. Yes, sir.
So this is if I substitute 4, what I will get? 11, right?
11.
11
Yes, sir.
minus 2
2. Yes, sir.
whole square, right? So if I compute this, what I will get? 0 plus
Yes, sir.
16, right?
Yes, sir. 4 square 16.
For 16, and I have 81, right?
Yes, sir. 81 square.
So more or less I'm getting 97, right?
97. Yes, sir.
So the sum squared error of this line with respect to this given data is basically 97, right? Right? Correct or not? So
Okay, sir.
this is how you compute sum square error. So instead of if you take some different line, okay, so let's say you have a line, let's say y equal to x plus 1. Okay, so if I compute the same thing, the same sum squared error of this line y equal to x plus 1 with respect to the given data, then how I should proceed? Can you tell me how I should proceed now?
So I think I can put values of x and find value of y in second line and then do the same method
Yeah,
as we do.
so can you tell me how, so what I have to do now? I have to put x equal to,
X is equal to 1,
then I will get 2, right?
y is equal to, yes, sir.
2 minus, then I have to subtract with 5, right?
Yes, sir.
So this is 2 minus 5 square. Then I will get 3. Then I will get 3 minus 11 square, right?
Yes,
And
sir.
then I will get 5. 5
5.
minus 2 whole square, right? So then what I am getting? I am getting basically 9 uh, plus 64, right?
Yes, sir.
Plus again 9, right? So
Plus
9,
again, yes,
9,
sir.
9, 18, 18 plus 64, I guess it's 82, right? Not 8,
92.
18 plus 64, right?
Yes, sir.
This is a 82, right?
Yes, 82.
So, so then this is the sum squared error. Okay, this is the sum squared error of this line, right?
Yes,
Of
sir.
this line with respect to this given data. Okay, and as you can see, this line has the minimum sum square error. Okay, if you compare these two lines, if you take
Yes,
these
sir.
two,
Yes, sir.
so certainly this has minimum, right? So this y plus y equal to x plus 1 has minimum. This is 82. Okay, so where you are getting 97. Okay, so the thing is, there is nothing special about this line. Okay, there is nothing special about this line. If you have any function, okay, so
Yes, sir.
if you have any function, let's say you have, if you have a function, uh, let's say you have some function p of x, right? Let's say you have a function, right? And you want to compute the sum square error of this function with respect to this given data, right? So then what you need to do? What you need to do now? You have to
I
you have to do the same process, right? So what you will do
Yes,
now?
sir.
First you will compute p of 1, right?
Yes, sir.
So once you compute p of 1, you have to subtract with what? You have to subtract with 5, right?
5
And you have to take the square,
square.
right?
Yes, sir.
Similarly, you have to find p of 2,
P of 2
and then you have to subtract with 11,
of
and you have
11.
to take
Yes,
the
sir.
square, right? And similarly, you have to find p of 4,
P of 3. P of 4
p of
and
4,
subtract
and
from 2.
subtract with minus 2 whole square.
Yes, sir.
And then this is basically your sum squared error. Okay, this is the sum squared error of this function p of x with respect to this given data, right? So that is how actually you need to do for this question. Okay.
Sir, I have a question here.
Yes.
Uh, can you just scroll to the page where you have written?
Yeah. Sure.
Yeah. Here you have written P of 1 minus 5. Is there any specific thing like calculated minus actual or actual minus calculated? Does it tell?
It doesn't matter because you have a square term here, right?
Yeah.
So
When it is squared, it doesn't matter. But when in our mock question, we have encountered a problem like they have only asked for error. So in that case, what should we be doing?
no, sum squared error means you have to always you
No,
have to take the
no.
square.
They just asked the error, not some squared error. And the answer was 1.6, but in the other way it was
No, not 1.6. I guess, yeah, probably 1.6 or 1.5. I remember. Yeah. So there is,
yeah, it,
I
it was
understand.
1.6, but if we use a
Yeah.
different thing like it was
I,
minus 1.6,
I,
I think I
I,
have raised this.
I understand. So okay. So my suggestion is slight. So the question is, I guess, slightly ambiguous. But in
Okay.
generally, when you are trying to find the error, okay,
Hmm.
most likely try to take the positive thing. Okay.
Okay.
So
Okay.
you take the modulus of the difference. Okay.
Yeah. In qualifier and all, we won't get such ambiguity, right?
Yeah. Mostly you will not get such kind of ambiguity. Even if there is some ambiguity, then definitely you will get the grace mark. Okay. Don't worry.
Okay. We will try to take the modulus, right?
Modulus. Okay. Yeah. Whenever you are trying to find the error, always take the modulus.
Okay.
Yeah. Okay.
Thank you.
Yeah. Thanks. So the thing is, if you see now the question number 20. Okay. So now you can easily find out the sum square error. So basically what you have now? Okay. So now you have xi. Okay, and
Yes, sir.
you have yi, right?
Yes, sir.
And you have a function r, right? You have a function r.
Yes, sir.
Okay, so so the thing is, it's saying he picked. So okay, let me read the question. A curious student created a performance profile of his favorite cricketer as r, which is basically it's a function of x, and the problem is here you have a constant c. Okay, so this is unknown. Okay, so, and where r is the total cumulative runs scored by the cricketer in x matches. He picked three starting values shown in table 2 and tried to find the value of c. Okay, so the question says, if he uses sum squared error method, then what will be the value of c? Okay, what will be the value of c? So the next thing is, now we need to find the sum square error. Okay.
Yes, sir.
So for that, what we have to do? We have to find R1, right?
Yes, sir.
R2
And R3.
R3, right?
Yes,
And
sir.
then what we have to do? We have to R1 minus y,
minus 120. Yes,
yeah,
y1.
y1 square, and I have to do it for all the values. I
Yes,
equal to
sir.
1 to 3, right? So if you, so basically you can see they have computed R1, R2 and R3. So as you can see, R1 is basically 125 plus C, right?
Yes, sir.
And R2 is 284, okay, uh, plus C, okay, and R3 is basically 363 plus C, right? So now
Yes, yes.
if you compute the sum square error, okay,
Yes, sir.
okay, if you compute the sum square error, so you have a C, right? You don't know the value of C, right?
Yes, it's
So
variable.
yeah, C is a variable, so definitely if you compute, then you will get this thing, okay, right? So if you
Yes, sir.
compute, you can check the calculation, okay. So now basically what happened in sum square error, you always want that sum to be always minimum, okay. So in sum square error, you always want this to be, this C to
Minimum.
be, this function to be minimum. So you want a value of C so that this function will give you a minimum value, okay. So now this is a parabola, right?
Yes, sir.
So now you can compute the value of C for which it will give a minimum thing.
Yes, sir. Yes, I will.
That is basically minus b by 2a, right?
Yes, minus.
Yeah. Is it clear now?
Yes, sir. It's clear now. Thank you,
Yeah.
sir.
Yeah, thanks. Okay, so any other doubt?
Hello.
Yes.
Sir, how to find the x coordinate when two polynomial equations are given?
Can you tell me the question number or which you want me to solve, or like
Uh, Sir, this is a question from a graded assignment
hmm,
4,
which,
where we have to find the x coordinate using the polynomial equations.
okay, graded assignment, I guess we should not discuss before the deadline, right?
Yes, sir, I know, but please, with the help of any other example, you just tell how to solve and find it.
No, I have tools for any other example, then certainly you can do it. Okay, so what is actually what you want to know? Can you tell me what you want to know?
Yeah, how to find the x coordinate using the two polynomial equations.
No, no, this question has no meaning. Like you are saying how to find the x coordinate. No, like certainly this question is not clear to me. How to find the x coordinate?
Yes, sir.
X coordinate or x intercept, or what do you mean by that? X coordinate is something different, x intercept is something different.
No, sir. X coordinate. So may I can read the question?
Just a minute, let just tell me the question number. Week 4, right?
Yes, sir. Graded assignment for question number 9.
Yeah, so here actually there is some meaning of x coordinate. So in generally, if you have some x coordinate, this has no meaning. So so basically, it's what basically it's saying that Ministry of Road Transport and Highways wants to connect three district with two roads, R1 and R2. Two roads are connected. Okay, so two roads are connected if they intersect. Okay, so if uh,
Sir,
if
I
they,
make the graph of this, but I'm not getting the third aspirational district that is x coordinate.
no, no, you don't have to make any graph. Okay, so you can do it without using graph. Okay, so so the thing is, as you can see, so you have two roads, right?
Yes, sir.
Mm. So uh, so let me tell you. So you have two roads, R1 right?
Yes, sir.
So this is, let's say, something, right? Some p of x, right? Some polynomial, right?
Okay, sir.
And R2 is another root, okay, which is
Okay.
q of x, okay. So it says basically two roads, they will intersect, okay.
Yes,
So
sir.
two roads are connected if and only if they are intersect, right? So basically what you need to do, you need to find the points where p of x, okay, this polynomial p of x and q of x will intersect. So how you can find the point of intersection? So first what you have to do, you have to, so at the point of intersection, okay, if this is your polynomial p of x, right? And if this
Yes,
is the
sir.
polynomial q of x, okay. So
Okay.
at this point, value of p of x is same as value of q of x, correct or no?
Yes. Yes, sir.
So now what you have to do, you have to equate p of x equal to q of x, right? So now if you equate, so you can now take this polynomial p of x minus q of x, which is basically 0, right? Now uh, you need to find the roots of this new polynomial p of x minus q of x, okay. So these roots will give you the point of intersection of these two roots.
That is called as x coordinate, right?
Not x coordinate. So if you have a, okay, so if you have a polynomial p of x, okay,
Okay.
so let's say x minus 2 and q of x is equal to x minus 2 into x minus 3, right? So so the thing is, yeah, so basically the roots, certainly these roots of the polynomial is basically is basically the x coordinate, that is correct. So the thing is, if you try to solve this, you need to find the points where p of x and q of x are same. So what you need to do, x minus 2 is basically x minus 2 times x minus 3. So now I can take everything in one side. So what I have, this is x minus 2 into x minus 3, which is 0, okay. So since this is 0, now I can take x minus 2 common, okay, because both the things have x minus 2. If I take x minus 2, then I'll have 1 minus x minus 3, which is 0, okay. So this is precisely x minus 2 x plus, okay, what is this? 4 minus x, correct?
Okay, sir.
So now x equal to 2, okay, and another is x equal to 4, okay. As so basically at x equal to 2 and x equal to 4, if this is a road and this is a road at x equal to 2, okay, so at x equal to 2, your both the polynomials are 0, right? So this is a point 2 comma 0, correct. And at x equal to 4, if you substitute, then what you will get, you will get 4 comma 2, right? So at these 2 points, this polynomial will intersect, okay. This is a point of intersection and this is a point of intersection, okay. And the x coordinate of this point is 2 and x coordinate of this point is 4.
Yes, sir. Same as this, I got the two answers, but there is no option to write both of the answers using the comma.
No,
Here,
there is no, you can't. Certainly, this question has not multiple answers. So, if you see in the question, so what will be the x coordinate of the third district? Okay. So, and it is given that if the first two are if, if the first two are at the x-intercept of f of x and g of x. Okay. So you have to exclude the x-intercept of f of x and g of x. Okay. So you will get 3 points, right? You will get 3 points and 2 of them are basically the x-intercept of f of x and g of x. Okay. You have to exclude them. Okay. So once you exclude these 2 points, then you are left with 1 point. So that is basically your answer.
okay, sir. Sir, I got the two answers.
No, you can't get the two answer. That is what I am saying. Right? So you have 3 points. You will get 3 points, and out of three, two are not correct. Okay, because in the question it is mentioned that you have to exclude the x-intercepts. Okay, so you have to exclude the x-intercept. So what do you mean by x-intercept? That is precisely the zeros of the polynomial, right?
Yes, sir.
So you have to exclude the zeros of the polynomial. So once you exclude all the zeros of the polynomial, then you are basically left with only one other thing. So that is your answer.
Okay, sir. Yeah. Thank you, sir.
Thanks. Okay, any other doubt? Is there any doubt or like?
Hello.
Yes.
Sir, I face some difficulty to understand the transitive relation example in book, sir.
Transitive example relation on the book. Okay. So
Yes,
can you
sir.
tell me
Example.
which one? What is your example?
Sir, transitive relations example.
Yeah. So tell me
Yes.
what is that example?
Second and third, sir. R2 and R3, sir.
Okay, then probably okay. Just give me a minute. I have to download that book and I have to say.
Okay. Page number 9 है, sir.
Yeah. So what is your doubt? Hello. Hello.
Hello.
Hello.
Yes, sir.
Yeah. What is your doubt?
Transitive relation.
Yeah. Transitive relation. Yeah. Yeah. Page number 9.
Yes, sir.
So yeah. So I have
Sir,
opened it.
okay, sir.
Hmm.
Example number R2 and R3, sir.
So this example R2 and R3. Yeah.
Yes, sir.
Yeah. So then what is your doubt in R2?
Here is here is given that R2 and R3 are transitive relations. Sir, how justify this, sir?
So it can you see the definition of transitive relation? It says, okay,
Yes, sir.
if for every pair of element xy and yz are in R, okay, this should imply
Yes,
that
sir.
xz in x comma z is also in R, right?
Yes,
So in R through you don't have any pair of elements, right? You have a single element.
yes, sir.
So then it is true vacuously, because you don't have, it's saying that in definition it's saying that if you have a pair of element, right? If you
Okay,
have a
sir. I
pair of element, then only you need to check whether x comma z is in R or not. If you don't have any pair of element, then certainly you don't have to check. It's vacuously true.
Okay, sir. Okay.
Clear now?
Yes, sir.
Similarly, you can see why R3 is also a transitive relation,
Yes, sir.
because again you don't have any in R3 also, you don't have any pair of elements like this x comma y, and y comma z. So then you don't have to check. So this is vacuously true. Okay, both R2 and R3, they are transitive bits. Okay. Clear,
Okay,
right?
sir.
Yeah. Any other doubt?
No, sir.
Okay, fine. Okay, is there any other doubt you want me to address?
Sir, can you explain the end behaviors again? It's kind of confusing sometimes.
Okay,
End
just
behavior.
okay. So give me a minute. Okay, I'll come back to my.
All right, all right, all right.
Yeah. So my screen is visible, right?
Yes, sir. Yes.
Okay. Cool. Yeah. So the thing is, what you want to understand the end behavior of a poly. Okay. So you just want me to discuss about only the end behavior, or like how to plot a graph?
No, sir. Just then, if we know the end behavior,
Yes.
then we can just plot the graph because we know zeros, and I mean personally, I know the zeros and whatever those are. So from where the graph is coming and where it's going. So if I can just understand that again,
Yeah.
because sometimes it's kind of confusing. So yeah, that's why.
Yeah. Okay. So the thing is, okay. So the main thing is the end behavior of a polynomial. Okay. It's completely depend on the leading coefficient of the polynomial. Okay, so once you know the leading coefficient of the polynomial, then basically you know the end behavior of the polynomial. Okay, so for example, if you take this polynomial, let's say p of x equal to something like x minus 2 into x minus 3. Okay, so this is okay. I'll increase my degree. Okay, just let me start with degree 2. Okay, so if I write it, then basically this is x square, right?
Yeah.
X square plus something else. Okay, which I don't care, because the only thing that decide the end behavior of the polynomial is
It's the
basically
first coefficient.
correct. This leading term, this
The first
leading
coefficient.
term will decide the end behavior. Okay. So as you can see, so the basically the leading term, so the leading term is basically x square for this polynomial. So if x tends to infinity, okay, if x tends to plus infinity, then it's clear, right? X square will also go towards.
Then it'll tend to infinity as well.
Yes. So if
Plus infinity, sorry.
yeah, plus infinity. So so basically that implies, since x square will go towards plus infinity, that basically implies my polynomial p of x will also go towards plus infinity. So as I said, this first term is basically it's kind of so basically it will dominate the behavior of the polynomial. Okay, so since x square is going towards plus infinity, that's why p of x will also go towards plus infinity. Okay, so and similarly, if you see, if x goes towards minus infinity, right?
Yeah.
So then similarly you can say that x square also
Will tend to minus infinity.
not minus infinity, because x square is
Oh,
positive.
x square. So yeah, it's yeah.
Yeah, it's positive. Again, it will go towards plus infinity,
Plus
and
infinity.
that means p of x will also go towards
Positive infinity.
positive infinity. So now if I want to draw this graph, then how I should proceed. So the thing is, as you can see, so this equation has two roots, right? Right. This equation has two roots. So one is 2 and another is 3.
It's 3.
So as you can see, as x tends to infinity, right? As x tends to infinity, your polynomial is going towards positive infinity, right?
Yeah.
So certainly it can't, this graph can't come from this down direction, right? It can't come, right? Because here the value of p of x is what? Negative, right?
Yeah, it's negative.
So certainly it can't come from this direction, right? So it has to come from the above, right? Because
Yeah.
p of x is infinity as a x tends to infinity. P of x is infinity. So then certainly it can't come from the below direction. It has to come from the above. So then the graph will come from this direction, right? And it will come to 3, right? Because
Yeah.
3 is a root.
Yeah.
So now once it reaches 3, then it will cross this x-axis, right?
Yeah.
Because
Since the degree is 1.
correct. So again it will cross the x-axis and again it will go towards
To the second. Yeah. To
second
the
root.
2.
2
Yeah.
root. Okay. And see, once you know the behavior of the end behavior of the graph in one side, then certainly then you don't have to know the end behavior of the other side. Or you can automatically draw by using the multiplicity of the root. Okay.
Yeah.
Since you know that this multiplicity of 2 is 1, then you
Yeah.
know that it will again cross this x-axis.
Just cross the x-axis. Yeah.
Yeah. So then this is your graph of the polynomial.
Okay. Perfect.
So similarly, so again, like if you have something like this, let's say p of x is equal to minus of x minus 2, x plus 4, and x plus 7. Okay. So suppose this is your polynomial, right?
Yeah. Yeah.
So now what will be the leading term of this polynomial? This is basically
Minus x cubed. Yeah.
minus x cubed, and you have some terms of some lower,
Like some lower degree.
which we certainly we don't care. Okay.
Yeah.
So now we just, so again, to draw the graph, we just need to know the behavior of the graph in one side, right? If you know the behavior of graph in a single side, then certainly we can draw the graph. We don't have to know the behavior in both the sides. Okay.
Both sides.
So as you can see, if x,
So we can plot the graph from left hand side also, no? Like is it necessary?
same. Okay, let me do it from the left hand side here. Okay, so for left hand side, then I have to check the behavior as x tends to minus infinity. Correct or no?
Yeah.
So for left hand side, I have to check what is the behavior as x tends to minus infinity. Suppose x tends to minus infinity. Okay. If x tends to minus infinity, then how this polynomial will behave?
So the x cube will also tends to minus. It will also tend to minus infinity.
And then we have a minus x also, right? See,
Yeah.
x cube will go towards minus infinity. Okay, but I don't have x cube here. I have minus of x cube here.
Minus
right?
of x cube. Yeah.
So that means minus of x cube will go towards
Go towards plus infinity. Yeah.
Correct. So then that means p of x will go towards plus infinity.
Plus infinity.
So if x goes to if x tends to minus infinity, then p of x tends to plus infinity. Okay. So now let me draw the graph. Okay. So now I know the roots, right? I have 3 roots.
3 roots.
So one is 2 minus 4.
Minus 4 minus 7.
Right. So this is, let's say this is 7. This is minus, okay, no. This is minus 4. This is minus 7. And this is, let's say this is 2. Okay, so you know that as x tends to minus infinity, p of x tends to
Plus infinity.
plus infinity. That means my graph can't come from
come
this
from the
side.
bottom side. Yeah, from the left
Yeah.
hand side. Yeah,
Yes,
left bottom.
correct.
Yeah.
It cannot. It certainly can't come from this side, the below side of x-axis, because x
Uh-huh.
is positive. So it has to come from the above side. Okay.
Yeah.
So again, it will come. Okay, sorry. Okay, so again, it will come from this side to 7, right?
Mm-hmm.
And 7, the multiplicity of 7 is
It's
basically
1.
1. Again,
1.
then it will cut this x-axis, and again it will come back to 4, right?
And
And again the
multiplicity is 1.
multiplicity is 1. Again it will come, cut, and again it will go, will come to 2. And since multiplicity of 2 is also 1, again it
It
will
will
cut.
just cut its axis. Yeah.
So the thing is, as you can see, once you fix this direction, okay, then automatically this fixes this side
The other
also.
direction as well.
Yeah.
Yeah.
Certainly, if you are applying the method correctly, that the multiplicity is odd and this multiplicity is odd and this multiplicity. So if you
Yeah.
apply this, maybe if you slightly change this rule, then probably it can change the direction of this side also.
Yeah. Like if any of those roots had like cube or something like higher degree, then in
Yeah.
that case the graph would like settle down in other ways according to the degree, something like that.
Yes, correct.
Yes, sir. Got it, sir. Got it. Thank you.
Yeah. Is there any other doubt from this part?
Hello, sir.
Yes, please.
Sir, I have a doubt in graph of polynomial turning point.
Hmm. Yeah, I was discussing that thing, right? Just now. Hello? Hello?
Yes, sir.
Yeah, what is your doubt?
Sir, can you explain the with the example?
Just now I have, so when you joined the session, can you tell me, like just now or
Now only, sir.
like how just now?
Yes, sir.
No, I have just now actually I have explained this thing. Have you asked all these things when I was explaining?
No, sir.
Oh. So yeah, so okay, so the thing is, okay, let me take some other example. Okay. So suppose you have this polynomial p of x equal to x minus 2 whole square, x minus 3, and x plus 1 whole square. Okay. So to draw the graph, so the first thing what you need to do, you need to find out the end behavior. Okay. So do you know how to find the end behavior of a polynomial?
Yes, sir.
Yeah, can you tell me how I can find the end behavior for this polynomial?
By solving x minus 2 whole square and x minus 3 by
So
a wave equation.
what is wave equation? What is wave equation? What is the leading term for this polynomial?
Sir, x equals to plus or minus 2 and x equals to 3. And then after that x plus 1 means we have to solve this given equation, that was p of x equals to x minus 2 whole square and x minus 3 into x minus 1 whole square. That's it.
What is the leading term of this polynomial? So basically, we are saying the roots. Okay, so the roots of this polynomial. Roots of this polynomial is basically 2, 3, and minus 1. These are the three roots of this polynomial. Can you tell me what is the leading term of this polynomial? Leading term.
Sir, I don't know.
You don't know the leading term? What do you mean by leading term?
No, sir.
Have you watched the lectures?
Sir, I am in lecture 5.
Lecture 5. Okay, you try to watch all the lectures. Yeah.
Okay, sir.
Yeah. Is there any other doubt? Is there anything else you want me to discuss?
Sir, am I audible?
Yes. Yes, you are audible.
Sir, um, I'm having a problem regarding how to solve polynomials in division.
How to solve polynomials in division?
I mean, how to divide polynomials.
Do you have anything on your mind? Any question you want me to discuss, or like, or because certainly there is a general method, but
Yes, yes, sir. Yeah,
what is your question? Like, so I basically what I want to do, I want to show you the step by solving one example.
yes, sir. Yeah,
Okay, can you tell me one question?
yes, sir. In activity 4, 6, I mean, activity question 6,
4.6,
week 4.
week 4. Huh.
Yes, sir. Week 4, activity 6.
No, activity C is in the sense what? Like activity 4.1.
Yes, sir. Activity 4.6.
4.6, question number?
Once.
Question number 1, right?
Yes,
Yeah.
yes.
So, okay, so you have a long polynomial. Just a minute. Just give me a minute. Let me take a photo. Okay. So basically, this is your polynomial. This is basically this is your dividend p of x, which is x power 6, 6 times x power 5 plus 17 times x power 4 minus 48 x cube plus 76 x square minus
Minus 24
24 x
plus 36.
36, right?
Yes.
And so what you want to do, you want to divide this polynomial, okay?
Yes, sir.
So you want to divide this polynomial, let's say this is, you want to divide this polynomial with some another polynomial, that is
Yes.
g of x. And what is g of x?
X square minus 6x plus 9.
6x plus 9.
Yes.
So basically, what in this polynomial, the degree is 6, right?
Yes, sir.
So this is 2.
Yes.
So you need to multiply something, okay? You need to multiply something with this polynomial, right? Such that you will get x power 6. So precisely you will get the leading term of this polynomial. So what you need to multiply with this polynomial such that you will get this leading term.
So I will get x.
Sorry?
I will multiply with that x power
X power
3. 3.
X 3. So if you multiply x power 3, then what you will get? If you multiply x power 3, what you will get? You will get x power
I'll get x power 6. X power 2 multiplied by x power 3 will get x power 6.
what is x power m times x power n? What is x power m times x power n? What is x power m times x power n?
It's
Sorry?
x x power m plus
X power
m plus m plus m.
m plus n, right?
Yes.
So if you multiply x power 3 with this polynomial, then what you should get?
I should get x power 6.
How come? You are saying x power m times x power n is m plus n, right? So if you multiply x power 3, right, you will get x power 5, right? So if you add 3 plus 2,
Right,
what you will
right.
get? 5,
Yes.
right?
Yes.
Not
Yes,
6.
sir.
So for that, what you need to multiply? Then what you need to multiply? Instead of x power
With
3, what you need to multiply?
I need to multiply with x power 4
Correct. Yeah. So now what I will do? I will multiply
with x power 4.
x power 2. Just a minute. Someone said here written. Same doesn't. Okay, I don't know. Okay, so now what you need to do? You need to multiply x power 4, right? So if you
Yes.
multiply x power 4, then what you will get? What you will get if you multiply x power 4 with this polynomial? What you will get? X power 6.
Yes, sir. X
Then
power 6.
then what next?
Next, I will multiply x power 4 with minus 6x.
So what you will get? 6 times x
6 times x power 5.
5. Then next thing is what you will get? 9 times x power
4. 9 times x.
correct. So this is now you need to subtract this one, this polynomial from the above polynomial, right? This polynomial, right? So you need to subtract x power 6 minus this thing. You need to subtract this one, the below one from the above. So now if you subtract, then what you will get? So these two things will get cancelled, right? This one
Yes, sir.
and this one, correct or not?
Yes.
So
Yes.
now what you will have? You will have this
7. 8. 8
9
power 8x.
or 48x cube plus 76x square minus 44x minus 36, correct?
Yes.
So now you have x square here, okay, and now you have x4 here, right?
Yes, sir.
So what you need to multiply with this polynomial such that you will get this thing 8 times x power 4. What you need to multiply with this polynomial so that you will get 8 times x power 4.
So multiply with 8.
8
8 x power 3.
if you multiply 8 into x power 3, then what you will get? If you multiply with this, then what you will get? So the first thing is you will get 8 times x power 5, right?
Right.
But I don't want 5, I want 4, correct or not?
Yes, sir.
So
Yeah. It's
then what I need to multiply? I need to multiply 8 times
8 times
x
x
power
power
2.
2. Yes.
So if I multiply 8 times x power 2 with this polynomial, then what I will get now finally?
I will get 8 times x power 4.
8 times x power 4, then
I will multiply 8 power x into minus 6x.
this is what? 48
Yes, sir. 48x cube.
Correct. Then you have 72
90. So 72
x
x squared.
square, right? This is what you will get. So now you subtract.
And
If you subtract,
it will,
then as you can see, these two
these
things
two will cancel.
cancel. Then what you will get? You will get 4
X squared.
square, correct?
Yes, sir. Minus
Minus
24x plus 26.
24x, right? So we have, so in the second process, we have multiplied 8x square, right? In the second step.
Yes, sir.
So I have to write
Yes.
here 8x square, x fourth plus 8x square. Okay. So here what I'll get finally plus 36, right?
Yes.
So the next thing is what I need to multiply with this polynomial x, this polynomial, such that in the leading term I will get 4x square. What I will multiply?
So I will multiply with 4.
4, correct. So I'll add 4. Okay, if I multiply 4 with here, then what I will get? I'll get 4x
4x squared
minus 24x plus 36.
plus 26.
So basically, so if I subtract, I will get 0, right?
0. Yes, sir.
So basically, now this process stops, right?
Yes.
So then basically what? This is the quotient, right?
Yo, okay, that is the question.
This is the quotient, okay. And finally, this is the remainder, this 0,
Yes, sir.
remainder, correct or not? And this is the divisor, right? This is the divisor.
Yes.
And this is precisely your dividend. Clear now? How you are you should do this division thing, polynomial division.
When I,
You are not audible.
I when I got in the
I don't know. Is it? I don't know. Certainly, you are not audible to me. Yeah, Pawan, you are not audible. Like, can you reconnect and can you join again and ask it if you have still any doubts?
Am I audible, sir?
Yeah, now you're audible.
Yes, sir. I got it, some, sir.
Yeah.
Thank you.
Yes, thanks. Is there any other doubt?
Sir, just one small doubt about turning points.
Hmm.
Sir, if the multiplicity is 2, let's say any for any kind of root, like it could be x minus 1, x plus 1, whatever. So so it's gonna bounce off the x-axis, I know that. So are we gonna take that as a turning point as well?
Yeah, certainly. When you have something like this, right? When you have something some shape like this one, right? This shape. Yeah. Then you have to take it this as a turning point.
So, sir, for the existing graph, if I take like let's say -4 has multiplicity of 2.
No, certainly you can't decide from the multiplicity. You have to draw the graph, then only so here if you see this graph, okay, this is a turning point, okay, and
And the top one as well.
and this is a turning point. So
Yeah.
this graph has two turning points.
Yeah, no, sir. I'm just saying, like, if -4 had like multiplicity of 2, so it would bounce off the x-axis, then it would go up and cut the x-axis and go its the conventional way, right? So
Yes. Suppose
when
you are saying that suppose the multiplicity of 4 is 2, right?
yeah,
So then it will come and it will bounce back, right?
bounce back.
And again it will go like this.
Yeah. So
Yeah.
in this case,
You have-
when it's bouncing off the x-axis at root 4 or -4, no, sorry, not 4, -4, are we taking that bounce off as a turning point?
Correct.
We're
Yes.
taking as a
Yeah.
so that was my doubt. Thank you.
Yeah. This is also a turning point. So
So
suppose you are coming like this, then you are again coming like this.
yeah.
Okay. Then again coming like this. So this is a turning point. Okay. This is a turning point. This is a turning point. This is a turning. Okay.
Okay. Got it, sir. Got it.
So
Thank you, sir.
in some sense, so
Mhm.
basically the turning point, okay, not I don't think it's completely correct, but in some sense where the slope of at that particular point is parallel to x-axis. Okay, so that is the idea. So if you draw at this point, if you basically draw the slope, this is basically parallel to x-axis. Okay, so you have to consider this point as well as this point also.
This point. Okay. Got it. Got it, sir. Got it.
Yeah,
Thank you.
yeah, correct. Any other doubt? Hello.
Yes, sir. You're audible.
Okay, fine.
Sir, another one.
Hmm.
So, sir, if the degree is very high for any
Hmm.
polynomial, so
Hmm.
we need to, so is there any like trick or kind of shortcut to find one root at least other than doing the hit or miss something?
So the thing is, okay, let me tell you. So in this course, okay, so particularly in this course, but in general, it's really difficult for you to find some at least even one root of a polynomial. It's really difficult. There are a lot of fancy algorithm to get some root of this polynomial. Okay, so in general, it's really difficult. It's a complicated problem. Okay,
Uh-huh.
but in this course, particularly whatever polynomial we generally we give you, so
Mhm.
mostly if there is any root, then you can find it by some hit and trial method. Okay, that is
Okay.
the idea. You try to put few values. Okay, you try to start with 0 and let's say 1, -1, 2, -2. Okay, most
Uh-huh.
likely if you go up to maybe 3 or 4, most likely you will get a root.
Yeah. See, sir, if we find one root, then we can just divide the entire polynomial and then
But
we can
okay,
just
so
do
I,
that.
I understand, but okay, in that case, then suppose you have a degree 7 polynomial, right? So
Yeah,
you,
yeah,
you
yeah.
know you know one root. Okay.
Mhm.
So if you divide with the x minus 1, then again you will get a degree 6 polynomial.
Oh yeah, then we gotta do it again.
Yes. So
Yeah.
the thing is that process is not easy. Okay. So as I said, there is no easy method to get the roots of some arbitrary polynomial. It's really difficult. It's not something easy. It's a research problem. Like if there are so many method. Okay. So basically, if you see even not exact degree, even some approximation that Newton-Raphson method. Okay, it
Uh-huh.
basically gives you the root of some polynomial or maybe some different function also. Okay, that method is not easy, but in this course, basically mostly we'll deal with very easy polynomials. So if most
So the
like
degree won't be super high, right? Like
no,
maximum 3 to 4, I
yeah,
guess.
yeah.
Okay.
And if certainly if we'll give you some degree 5 or 6 polynomial, then certainly it will come with bunch of hints. Okay, so that you
Okay,
so
okay.
so that you can easily get the roots.
Okay. Got it.
Yeah, so again, if you have any doubt, then please ask.
Sir, I found one more. So if a polynomial is like in the form of p of x is equals to x
Sorry,
squared.
sorry, sorry, sorry. Yeah, so, sorry,
Yeah.
sorry. Yeah. So
It's okay, sir. It's okay. So
I missed your first part.
okay. So if a polynomial is p of x is equals to x squared plus 5 into x squared plus 4.
Hmm.
So, sir, what and
P of x
is
equal to x
x squared plus 5,
square plus 5.
yeah,
Okay.
into
Hmm.
x squared plus 2, x squared plus 4.
X square plus 4. Okay.
And sir, it is given that there are two sets. One is S and one is R. S is the set of domains, and R is the set of the y-intercepts.
S is the domain of this polynomial.
Yeah.
S is the domain, correct?
Yeah. The set of the domain values.
Set of the domains. Domain
Yeah,
is set.
set. No, sir. Set. I mean the domain values, the set of the domain values.
Okay. S, correct.
And
Yeah.
R is the set of the y-intercept values.
Okay. Y-intercept. Hmm.
So, sir, for this given polynomial, we are getting complex roots, right?
Yeah, but nowhere it's asking about the roots of the polynomial.
No. I'm just saying. I'm just saying.
Yeah. Certainly
If I take,
it has 4 complex roots. Yeah.
yeah, so
Plus or minus 5i. No, sorry, square root of 5i
square root
and
of 5,
plus
yeah.
or minus
So,
2i.
sir, if I take the zeros as well, we can't take zeros, right? So it
No,
could be like any value other than the roots.
no, it has no real zero. This polynomial has
Yeah.
no real zero. It has only
But
complex zero. Yeah.
But sir, if in this question there is no mapping given like from n to n or r to r or something. So in this case, how are we supposed to find S union R? That's the question actually.
No, it's certainly S is something different. I guess. Can you tell me the question number? It seems S is something else. It's can't be domain. See, the domain of the polynomial is basically R, right?
Yeah,
This is a function from R to
R
R, right?
R to R.
So
Yeah.
so domain is basically R, right?
Mm-hmm.
So if you again the y-intercept they are basically points on R square, right? It's basically the point where the polynomial touches the y-axis, right?
Mm-hmm. Yeah.
So this is the polynomial that touches the y-axis, right? This point. So for that,
Yeah.
what you need to do? So you need to substitute x equal to 0, right? So
Yeah.
once you substitute x equal to 0, then basically p of 0 is what? This is 20, right?
Yeah. 20.
So that means this point is basically 0, comma 20, where this polynomial touches the y-axis.
Mm-hmm. Yeah.
So the y-intercept is basically 0, comma 20. Okay. So this is somewhere else. This is in R square. Okay. And this is in R. So this union has no meaning. Okay. So
So I think in that case I think I have written the question wrong. But
yeah.
but
So
but I got the point actually. Thank you, sir.
yeah.
I got the point, like how to find it or something. I got it. Got it.
So
Got
I
it.
guess yes, S is something else. Like you just need to. Okay, I remember there is some question, but I don't remember what is this set is. Okay, I guess set is this S is something different.
I gotta check the question again. So it's okay, sir. The point I got it. I got it.
Okay, fine. Okay, I guess no one else is asking question. Is there any question from your side, Santan? Sayan?
I'm trying to find. I'm not sure if I have any more.
No, if you have any doubt, like you can ask me. Like otherwise, most likely since no one else is asking question, then probably I can close the session. Otherwise, if you have any doubt, I can wait for a few minutes. Okay, that is not a problem.
Oh, okay, okay, okay. Yeah, let me just give me 2 minutes, sir, if I can find some more.
Okay, fine. Yeah, and yeah, anyone else have any doubt, you can ask.
No, sir, I don't have any, like for now, I don't have anything else.
Okay, fine. Yeah. Okay. Okay, then I'll close the session now. Okay, thank you all.
Thank you for the session, sir.
Thanks. Yeah.
Thank you, sir.
Thanks.